Airflow. Today, on Pellet Tech Talk. Airflow is one of the most important elements to a clean burning pellet stove. If the stove has a lack of combustion air, it will manifest in a dirty or lazy fire, and may cause pellets to back up in the pot. All combustion air is driven by the exhaust fan. When the exhaust fan engages, it forces the combustion gases out of the main chamber, and into the exhaust venting. This creates a negative pressure that causes replacement air to be drawn through the stove. From the intake port, the air is then drawn into the cradle area, and up through the pellets in the burn pot. The combusted air is then exhausted through the rear chambers and out of the stove again through the vent piping to the outside. This is referred to as the total airflow combustion circuit. When this circuit is impeded, it can interfere with the successful burning of the pellets, and can cause undesirable effects. There are three main airflow problems that can occur: restrictions, negative pressure leakages, and combustion motor failures. We will now examine all three of these in greater detail. Restrictions happen when some part of the airflow circuit becomes blocked, either fully or partially, by soot or debris. These are the most common sources of an airflow restriction. 1. The burn pot. If the holes in the bottom of the burn pot become blocked, then the air has no way to come up through the pellets. This is devastating to the fire, and can lead to major pellet backups. 2. Rear exhaust chambers. Fly ash and other sooty debris gets carried up from the burn pot and deposited into the rear chambers. This can lead to severe restrictions without regular cleaning and maintenance. See our cleaning and maintenance video series for your particular stove model for more information, and best practices on keeping your stove clean and in good working order. Links will be in the description. 3. Exhaust venting. Another place restrictions can happen is inside of the exhaust piping. Make sure to empty traps and clean out tees, and schedule regular inspection and cleaning of your exhaust venting. The cleaner the venting, the better the stove will function. 4. The air damper. There is an air damper located at the base of the intake pipe. If this damper is pushed in too far, it can restrict the airflow and cause issues. If the damper is pulled out too far, it can cause the flame to be lower than normal. A good starting location is about halfway open. Another problem that can be equally detrimental to the airflow is leakage. When you hear leakage, you may imagine smoke and carbon particulates coming into the room. This is not the airflow leakage that we are referring to, but rather a negative pressure leakage, where air gets sucked into the stove. As stated before, when the stove is running, the main chamber is under a sort of vacuum, or negative pressure. If there are places where the gaskets are weak, the stove will have a tendency to draw air from the room into the main chamber. Any air that enters the stove this way is bypassing the combustion process and robbing the fire of much needed air. These are the most common places where airflow leakage can occur. 1. The burn pot. Make sure that the burn pot sits flush on the cradle. Any gaps between the cradle and the burn pot can act as a path of least resistance for the airflow. The air can escape out from these gaps, instead of being drawn up through the pellets, which will rob the fire of oxygen, and can lead to pellet backups. 2. The ash pan. If your stove has a removable lower ash pan, make sure that the latches are snug and have about equal pressure. One side being tighter than the other can cause gaps on the weaker side. 3. The main front door. Inspect the braided rope gasket around the door to look for fraying or flat spots. A good way to test the seal is with a strip of paper. You can shut and latch the door with the paper in between the gasket and the body of the stove. Now try to pull the paper out. There should be significant resistance, and you should not be able to easily pull out the paper. 4. The clean-out chamber covers. After removing the cover plates a few times to clean the rear exhaust chambers, the rectangle gaskets may become thin or tear. If the gasket no longer seals, it can allow air to be leaked directly into the rear side of the exhaust, robbing the fire of that needed oxygen. The combustion fan is the most important component of the total combustion circuit. If this fails to spin, there will be no air moving in or out of the stove. When troubleshooting, a good starting point is to put a small piece of paper at the 2-inch intake port to see if there is a noticeable intake of air being drawn in. If there is no noticeable air draw, check to make sure that the exhaust motor is turning on and that the fan is rotating. When the stove is running, these outer fins should be rotating. If they appear to be stuck, you can try manually flicking them to see if they dislodge and allow the fan to spin freely. From time to time, Birds, bugs, or other small critters can get into the piping and seize up the combustion motor, which would need cleaned out before operation can resume. See our exhaust fan replacement video for instructions on how to replace if necessary. Links will be in the description. So to recap, check and clean out any airflow restrictions. Check for loose or leaky gaskets. And make sure the combustion fan is working as intended. And that's it. You're all set. Thanks for watching. Until next time, on Pellet Tech Talk.